Hello Potato! Welcome to the third installment of my Pixel Fire Geometry Nodes tutorial series. In this video, we're going to be creating fire. Using what we have learned in the previous two tutorials, we will be combining the instance grid and proximity node groups to generate a three-dimensional cube grid to create a cube ball that will be used as our fire. Let's jump right in. Using the Blender file from the previous tutorial, we can just modify our existing node groups. Go ahead and open up the Proximity Blender file and save it as a new Blender file called Pixel Fire. Open up the Geometry Nodes window and select your cube grid object. The first thing that we want to do is to extend our 2D point grid into a three-dimensional point cube grid. Tab into the point grid node group. In order to duplicate our grid mesh on the Z-axis several times, we will need a mesh line node. This node will create several vertices that we will turn into points, and instance our grid mesh on each of those points. Add a mesh line node and a mesh to points node and connect the two. Then, add an instance on points node and plug the mesh to points node that we just created into the points input. And plug our grid mesh node into the instance input. Now plug the instance on points node into the mesh to points node. We actually need another node between the instance on points node and the mesh to points node, but in order to better explain why we need this node, I first have to show you what happens without the node. But first, in order to be able to control the Z-axis values such as Z-distance and Z-count, we need to add one more node. Plop in a combine XYZ node. And plug the Z input into an empty slot of the group input node. Plug the vector output into the offset input of the mesh line node. And plug the count input of the mesh line node into an empty slot of the group input node. Rename the inputs to Z spacing and Z count. And move them with the arrow buttons to where you feel they will best fit. Tab out of the point grid node group and change the Z spacing to 1. Connect the Z spacing and Z count inputs of the point grid node group into empty slots of the group input node. If we look in the 3D viewport, we will notice that when we move the empty object, all layers of the grid cube are the same. This is because each of the grids that we are instancing are still considered as the same grid, or instances of the same grid. So, changing a point on one of the grids will change the same point on all of the grids equally. What we want to do is to convert each of the grids to their own object, so they are not linked to one another. For that, we will be using our trusty Realize Instances node. Tab back into the point grid node group. Throw a Realize Instances node between the instance on points node and the mesh to points node, and everything will be just fine. Currently each cube is about 1 meter in size. We can change the size and spacing in the modifier, but we would require multiple decimal places. To make things a bit easier, let's use some math nodes to already scale the cubes to the right size. Duplicate one of the other math nodes and set it to divide. Set the bottom value to 10 and plug it in between each of the X, Y and Z spacing positions. Tab out of the point grid node group and go into the proximity node group. Add a vector math node and set it to divide. Set all values in the bottom slot to 10. Plug the vector math node in between the group input node and the multiply vector math node. Adjust the values in the modifier till you are happy. One thing that I would like is to be able to scale the empty object and have that influence the size of the fireball. Add 2 math nodes and set them to multiply. Plug them in between the from min and from max connections. And plug the scale output of the object info node into the 2 math nodes. Test if the scaling works by playing around with the empty object. If everything works perfectly fine, you can then tab out of the proximity node group. Let's also expose our proximity node group settings by dragging each of the inputs into empty slots of the geometry nodes group input node. In the group input settings tab, set the vector input type to float. Name it as cube size. Change the default to 1 and the min value to 0. You can also change the value in the modifier window to 1. Play around with the values to get the perfect size and resolution that you would like. The next step is to stretch the top part of our fireball to form a flame shape. We also still need to add some noise and movement to our cubes to make it look like flames. Grab your tiny umbrellas because it's time for some brainstorming. Let's start with the stretchy bit of the flame. We only want the top part of the flame to be longer and the bottom part to be the same as the width. See if you can figure this one out for yourself by pausing the video right about now. Okay, unpause. If you couldn't manage to figure this one out, don't worry, no one will know. It's actually quite simple really. All we have to do is to make the geometry nodes think that the instance is closer to the empty on the z-axis by faking it. We just multiply the z position of each instance by a value of less than 1. This way, if say the instance was supposed to be closer than 2 units from the empty but it's actually 4 units far, we multiply the z value by 0.5 and that way Blender thinks that the instance is actually 2 units far instead of 4. Let me show you. Tab into the proximity node group. Duplicate the distance vector math node and set it to multiply. Plug that in between the position node and the distance node and set the values to 1. Duplicate that math node and plug that between the object info and distance node. Next, add a combine XYZ node. Set the values to 1 and plug that into both multiply nodes. Now, change the Z value to smaller values such as 0.5 and check in the 3D viewport if something happens. Next, we only want the top part to be stretched out. We need to detect that if an instance is above the empty, it may be further away on the Z-axis before scaling, and if it's below the empty, it should not be allowed to be further away before scaling. Add a math node and set it to greater than. This will output a 1 if an instance is above and a 0 if it is below. Next, we only want the Z value to be detected, so add a separate XYZ node and plug the position node into it. Duplicate the separate XYZ node and plug the location of the empty into that. Finally, connect the Z output of the node connected to the position node into the value slot of the greater than node, and the Z output of the node connected to the object info node into the threshold slot. We already have the top instance's distance, so to get the bottom instance's distance, duplicate the distance node and plug the position node into it, and the location output of the object info node into it. Now add a switch node and set it to float. Plug the distance node that will be calculating below the empty Z value into the false input of the switch node, and the other distance node into the true input. Next, plug the greater than node into the switch input, and plug the output of the switch input node into the map range node value input. Check in the 3D viewport if it worked. One last step is to expose the flame height value that we want to adjust. To do this, add a math node, set it to divide and change the values both to 1. Plug the output into the Z input of the combine XYZ node. Next, plug the bottom input of the math node into an empty slot of the group input node. Call it flame height and set the min value to 1. Tab out of the proximity node group and plug the flame height input into an empty output slot of the group input node. Awesome! Now we can adjust the flame height right here in the modifier tab. Next, we need to animate our flames with time. The idea is that we use noise to multiply our instance size and animate the noise position and instance position to move upward on the Z axis. So let's start there. Add a noise texture node. To animate the position vector of the noise texture node, we will need a position node. Next, we want to offset the noise position through time. Add a vector math node and set it to add. Plug the position node into the top slot and plug the vector math output into the vector slot of the noise texture node. Now to get the time in our animation, add a scene time node. This gives us two options, seconds and frames. Since we want the position to change every frame, we will be using that. We also want to adjust the speed at which the noise moves, so add a math node and set it to multiply. Since we only want the noise texture to move on the Z axis, we will need to use a combine XYZ node and plug the math node into the Z input slot. Plug the vector output of the combine XYZ node into the vector math node. To influence the intensity of our noise, we will need a map range node. Plug the factor output of the noise texture into the value input of the map range node. Alternatively, you can use the color ramp node, but I have found that you can't adjust the intensity of the noise in the modifier window, so I decided on the map range node instead. Add a vector math node. Set it to multiply and place it between the proximity node group and the instance on points node. Finally, plug the map range node into the bottom slot of the multiply vector math node. Now to clean up a bit. Select all the nodes that we just created and turn them into a node group. With our current node set up, our noise texture will be moving way too fast. By the time we get to frame 100, our noise will have moved 100 blender units within 4 seconds. Make sure you are inside the new node group. Duplicate the multiply node and set it to divide. Set the bottom value to 100 and plug it into the bottom slot of the multiply node. Plug an empty socket of the group input node into the top socket of the divide node and call it flame speed. Duplicate the group input node and move it up to the noise texture. Plug an empty slot into the scale input of the noise node and call it noise scale. Also plug an empty slot into the 2 min and another into the 2 max inputs of the map range node. Call them noise min and noise max. Tab out of the node group and call it noise. Plug all the inputs of the node group into empty slots of the group input node. We also need to move the cubes along with the noise. Tab into the point grid node group. Next, we want to move our point grid's instance points. Add a set position node. Plug it in between the mesh to points and instance on points nodes. If we move our point grids on the Z axis, eventually we will run out of point grids and our fire will end. To prevent this, we will fake our points to look like they are moving up by wrapping them back to their original positions the moment they reach the point that is above them. Add a vector math node and set it to wrap. Plug the wrap node output into the offset of the set position node. Now plug the combine XYZ vector output into the max socket of the wrap node. This will jump the instance point back down by the distance that is between it and the point above it. To make the points actually move with time, we will be doing the same that we did with the noise texture. Pause the video now if you'd like to attempt this part by yourself. We only want to influence the Z axis, so add a combine XYZ node. Next, add a scene time node and plug the frame output into the Z input of the combine XYZ node. Now add a math node and set it to multiply. Plug it between the scene time and combine XYZ nodes. Duplicate the multiply node and set it to divide. Set the bottom value to 100 and plug it into the multiply node. Finally, plug an empty socket from the group input node into the top slot of the divide node and call the new group input socket something like flame speed. Tab out of the point grid node group and plug the flame speed socket into the group input flame speed socket. There's one final thing that I would like to do. If we look in the 3D viewport, we will notice that there are hundreds of these tiny little specks. We will also notice in the information part that there's 1 million vertices, depending on the settings that you have used in your modifier. What I would like to do is for Blender to delete each one of these instances if they are smaller than a certain size. In the Geometry Nodes window, grab all of these nodes and move them to the side. Next, add a Separate XYZ node. Plug the Multiply Vector node into the Separate XYZ node. This will output each of the separate axes of the scale of our instances. Next, add a Math node. And set the Math node to less than. Plug the Z output of the Separate XYZ node into the value input of the less than node. Next, we want to be able to change the threshold value of the less than node outside of the Geometry Nodes window so that we can determine the minimum particle size. Plug a new output slot from the group input node into the threshold value. In the End tab, call the new socket min particle size. Set the minimum value to 0. What the less than node does is it outputs a 1 if our instance is smaller than the min particle size and a 0 if our instance is larger than the min particle size. Add a Delete Geometry node. Plug the Delete Geometry node between the Instance on Points node and the Capture Attribute node. Change the Delete Geometry node type to Instance. Now, plug the value output of the less than node into the selection input of the Delete Geometry node. If we go back into the 3D viewport, we will see that our fire has completely disappeared. Decrease the min particle size value in the Modifier tab until you start to see particles. Now you will notice that all of the tiny specks have disappeared, and the scene vertices has decreased from 1 million down to 3000. We are finally done with our pixel fire. Play around with the settings in the modifier window until you are happy. Next, we want to improve the shader a bit. So let's jump into the shader editor window. We want our fire to emit some light, so plug the color ramp into the emission input of the principal BSDF shader. Also, play around with the color ramp color settings until you are happy. Also, enable bloom for some nice visual effects. And there you have it, a nice Geometry Nodes pixel fire. And that concludes this tutorial series. I hope you liked it and comment down below what you thought or struggled with in this tutorial series. Also feel free to make suggestions on tutorial series that you would like to see in the future. Press that like button if you enjoyed this tutorial, and don't be afraid to subscribe for more cool tutorial series like this in the future. Tjots!